Hi, this is just a brief video to show how we evaluate caps for sorting on a waterfall type sorter. You have a little jig. It's got a degree readout. If I zoom in close, you should be able to see that. There you go. And that can swivel like so. And you have a small precision vise. It's like a machinist vise used for surface grinding. And if you wanted, you could just glue that vise into the pocket on the angle position, but I've got a little clamp that I made. That's basically so I could take it apart and actually use it for machining when I want to. So what that allows us to do is we have a backstop that's aluminum extrusion, and it's taller than most of the caps are going to be. And if you have access through a slot to the screw that lets you open and close the clamp, and then you have a wide variety of just plastic blocks that can be clamped in there to simulate what the flight design would be. And here, there's a whole box of different styles. There's just a bunch of them machined to different angles, different steps, reverse tapers, and just in general, whatever profile you might need for a cap. You can put multiple ones together to make steps to save on machining. Sometimes you do have to machine them custom, like for example, here's a sport cap, and it's got a certain profile that was machined specifically to match the shape of the cap, and then this whole piece gets inserted into the device for sorting. Now, this particular overcap that we're looking at here, I was hoping to do with a flight that looked more or less like that. And if you look at the different correct positions, they're quite stable, and by quite stable I mean that how many degrees they can lean forward without falling off. And that includes with this reversed, and it also includes with it sideways. With sideways, it's a little bit less stable, but still pretty stable. And if you look with it sideways, it's going to roll off at a substantially shorter angle. You see, it's basically at 90 degrees, whereas before it was about 10 degrees past 90. And if you have the weight of this thing on here at different angles, you'll see most of them will fall off quite a bit sooner. However, the problem with this part is if you put the heaviest side against this would be the belt of on the sorter, and you go forward, you'll see it has to lean quite a bit forward, basically almost to the same point as the correctly oriented caps before it falls off. And the same thing with it upside down with the weight forward. That's also quite stable. So if this part were tapered on both sides the same amount that it is on in this area right here, you might be able to make the flight above it the same shape and put them close enough so that it would reject this. But this part is almost exactly the same height as diameter. So you can't really create, you can't physically prevent them from going in this orientation. That was my original hope. Just at a glance, I thought it might be possible, but when you lay it out, you find out that that's not going to happen. You basically, if you can't sort them based on the shape of the shelf, you can't reject them based on the shape of the cleat above it. That does work in quite a few cases, so it's a good one to keep in mind, but for this, it's not going to fly. So, give you a little idea how we do it. It doesn't have to be identical, but if you ever wanted to, from that, I would say you could design a fixture that would tell you how well something whether something is a good potential candidate for sorting on a waterfall machine. And just as a side note, a lot of waterfall machines are just made with standard cleats, and they didn't even try to design the flags to do this. We are one of relatively small number of companies that make the custom designed waterfall sorters where the belt is specifically for the parts, so that we do a wider variety of parts, but every feeder type has its limitations, and unfortunately, this is one of ours. All right, thank you very much. I hope that's helpful for future selection of candidate parts. Bye.